My name is Jennifer Burkowski, and I'm the coordinator of mathematics in Saskatoon Public Schools. And I'm really an opportunity to work with Shauna and Tracy and start digging into how we can support our English language learners as well and so this is kind of the first of what hopefully will be a little bit of a journey for all of us, a learning journey where we can dig deeply into this idea and start coming up with some not solutions, but some solutions, yes, but also some opportunities for the students that we have in our schools. So to start off with today, I just thought that we would do a little bit of a notice and wonder. So I put there's 5 different statements that would be very common in a math classroom that you would hear if you were going in classroom. And so through your EAL lens, take a look at some of those statements and think what comes to mind. What do you notice? What do you wonder when you take a look at those statements? And for those of you online, you can type them into the chat. And for those of us here, we'll have a conversation. Yes. So math is its own language, and there's lots of words that we use in math all the time that are specific to a concept in mathematics, but have a very different definition in everyday English. The idea of round, you're right. Like oftentimes students will think of, or children will think of a circle or something that you go around. In this case, rounding the number is rounding to the nearest benchmark that we want, either up or down, but we're rounding the number. And so we're making the number bigger or we're making the number smaller, which is a very different definition than round. Even the idea of reduce the fraction. And reduce the fraction is to put it into its simplest form with the lowest numerator and denominator possible. But reduce in English make smaller, and when we reduce a fraction, it's actually equivalent to the larger fraction. It's the same. And so just even like using language like that can be really complicated for a lot of our English language learners. The idea of table or times or a pattern core. A pattern core in math is the part of the pattern that repeats. It's that essence of the pattern that you see over and over and over again. But the word core is often the middle. Right? We think of an apple core or something like that. So the definition of the word core in math is different than the definition that our students might be exposed to. And this is why math can become, and often is for our English language learners, something that is really difficult, because mathematics and language are linked, and they absolutely are. So I found this quote from a book called The Problem with Math is English, and it really resonated with me, and I thought it might be a jumping off point for our conversations today, because math and language are linked, and language is the vehicle for conveying math knowledge to our students. It is the vehicle our teachers are using in the classroom. And so when our students have difficulty with the language, then it could potentially break down their comprehension of those concepts. And a lot of times is what we have, or what we try to do in our classrooms, is we strip the language out and just leave the numbers so that they can continue to be successful in the mathematics. But what we justify, or what we lose when we do that, is understanding. We have temporary understanding of those concepts at that moment of time, but as we continue to extend the concepts and make complex and more abstract, that loss of comprehension will become very apparent and will become very detrimental for students' understanding. So we have to, as we're working through mathematics, have to think about the needs of our English language learners as well, which is why I'm excited to begin this journey with you all today.
In the video, Jennifer mentions that students may understand at that moment. In fact, language learners, even though they appear to understand, may not have the ability to store their learning in their working memory, and may therefore forget what they've appeared to comprehend earlier. David Sousa, in his book How the ELL Brain Learns, explains why this might happen. You can see in figure 6.2 the explanation of the working memory. If a student's working memory is really spent on language processing, they have less memory to work on mathematical processing. As their language proficiency increases, then they have the ability to use their working memory for more mathematical processing.